Okay, so two new things, difference of squares and perfect squares. So you'll be able to tell what a difference of squares is when you have this subtraction in the middle and when both the first and the last term have a perfect square root. So what are numbers that have a perfect square root? Give me examples. 9, so what's the square root of 9? Okay, another one. 25, what's the square root of 25? 5. Okay, now when it comes to variables, when we take the square root of a variable with an exponent, all we're doing is dividing the exponent by 2. So if I were to ask you guys what the square root of a to the power of 2 is, what would it be? You're just taking the exponent and dividing it by 2. So it's a. How about a to the 6? What would that be? A to the 3. Do we have a square root of a to the 5? No, because when I divide 5 by 2, I get a fraction. So this would be 5 over 2, but we're not going to worry about that. So all of the exponents that we're going to use will have a perfect square. So that is the difference of squares. That is the easiest one. So whenever you factor out a difference of squares, you're going to have your two brackets. One bracket is going to have a subtraction, and one bracket is going to have addition. And then we have something called a perfect square trinomial. So when we have a perfect square trinomial, that is when we take a trinomial, we do the sum and product, but we're going to notice something unique. So let's say I have x squared plus 4x plus 4. How would I factor this simple trinomial out? Olivia. Yep. So product is equal to 4 and sum is equal to 4. So what are two numbers that multiply to 4 and also add up to 4? Jade. 2 and 2. So 2 times 2 is equal to 4 and 2 plus 2 is equal to 4. Perfect. So what are my two brackets going to be? Jade? Someone? Sarah? Yeah. So what do you notice about both of these brackets? They're the same, right? So whenever I have two of the same brackets, I can also write it as x plus 2 to the power of what? 2. So that is what is a perfect square trinomial, is when you have both your sum and your product use the same factors. Both numbers have to be the same. So 2 times 2, 3 times 3, 4 times 4, and so on. So let's take our first example. So we have factor if possible. So we have x squared minus 25. So is this a perfect square or a difference of squares? Difference, because you have this subtraction in the middle. So what I usually like to do is I like to take the square root of both terms first. So what is the square root of x squared? Square root of x squared. X. Now, Ashton, what's the square root of 25? 5. So we're going to write both brackets. One is going to have a minus, one's going to have a plus. So what did we say the square root of x squared was? X. So the first term of each bracket is going to be x. What was the square root of 5? Or what was the square root of 25? 5. So my last one is going to be 5. So we have x minus 5x plus 5. So that's as easy as it gets. Yeah, Jade?
How did you know that one bracket would be negative?
So we're used to writing trinomials as, let's say, x squared plus 4x plus, let's say, a number 4, right? what is in the middle over here? A 4x, right? Do I have anything in the middle in a difference of squares? No. Okay, that's why we can do a difference of squares. It's because we only have the x squared part and then the last part.
So if it's a difference of squares, we'll have a negative.
So the difference of square only has minus in the middle. So it'll always be x squared minus 25, x squared minus 9, a squared minus 4, and so on and so forth. So a difference of square has no middle term. It just has two terms. So the next one you guys should be able to do on your own. I have y squared minus 49. Let's see what you guys can come up with. Olivia?
I got y minus 7, y plus 7.
Yep. So again, difference of squares because we have the subtraction. I know the square root of y squared is just y, and the square root of 49 is just 7. Yes, read up.
When we're looking at like square root 49 here, we don't consider the
No, not the negative.
sign,
Nope,
right?
you just take the number for what it is.
Okay.
Yes, Emma?
Will there ever be an instance where it won't be a negative and a positive?
No. Difference of squares always has a negative and a positive in the brackets.
Does it matter which was first?
Nope, you can put y plus 7 first, y minus 7 first, doesn't matter to me. When you FOIL it, it will still give you y squared minus 49. Okay, the next one we have is y to the 4 minus 1. So what is the square root of y to the power of 4? Read up.
Y squared.
Y squared. And what's the square root of 1? 1. So now try to figure out the difference of squares. Emma?
Y squared minus 1 and then y squared plus 1.
Okay. Now, are we done yet? No, why aren't we done yet? Do we have another one that's a difference of squares? If you look at both brackets,
Yeah.
which one? Y squared plus 1 or y squared minus 1? Yeah, remember difference of square always has a minus in the middle. So this guy over here is also a difference of squares. So what is the square root of y squared? Y, and we have the square root of 1 is just 1. So in reality, what is my actual final answer? Olivia?
Y minus 1, y plus 1.
Okay, you're missing the other one. Remember? The one that we have up here also counts.
Oh, it's everything?
You also have to keep it.
Oh, okay. Y squared minus 1, y squared plus 1.
Yep. So even though you did another difference of squares, you still have to keep that y squared plus 1 throughout. Yes, Emma?
So anytime there's a difference of squares, you need to keep going until there's
Yep.
no more.
You can keep going until there's no more.
Only for the difference.
Only for the difference of squares.
Wait, so it would be y minus 1, y plus 1.
Y squared plus 1. Yep,
But
that's it.
Why would we write y squared?
Because we already did y squared minus 1 as y plus 1, y minus 1.
Wait, so then why would you keep the y squared plus 1?
Because that can't be a difference of squares. But it's still it's still a factor. Okay. Now we have z squared plus 64. Oh, sure. So the reason why we have to keep y squared plus 1 is because even though it's not a difference of squares, it's still a factor from the whole expression. So we have to keep it throughout, even though we can't do a difference of squares again.
So it just can't always win.
Pardon?
It just can't always win.
Well, This one was we were able to get x minus 1 and x plus 1 because x squared minus 1 follows the rules of difference of squares because there's a subtraction in the middle, right? However, x squared plus 1 has a positive. So difference means subtraction. Because it's a positive, there's no such thing as an addition of squares. You just leave it as is. So the next one, you guys probably saw, xz squared plus 64. Is that even possible or no? Look at the operation in the middle.
Plus.
Yeah. So is it possible or not?
No.
No. This is not possible. It's not possible because we have addition in the middle. Remember, a difference of squares, difference means subtraction.
If it's not possible, just
Please tell me we're never gonna have to figure out if it's not possible.
Oh, you'll notice right away. It's just
Okay,
What's in the middle?
just do like perfect square trinomial or something?
Pardon?
Wouldn't you do like perfect square trinomial?
no. Perfect square trinomial has to have x squared plus something x and then plus a number. Now the next one, 4a squared minus 9. So is this a difference of squares? Yeah, because we have the subtraction in the middle. So we have to take my first term, which is 4a squared, and take the square root. So start with your number first. What's the square root of 4? 2. What's the square root of a squared? Which means the square root of 4a squared is 2a. Now square root of 9, 3. So now you can put the difference of squares together, which would be what? Yep.
does it matter the order you do it in?
Doesn't matter. Because when you FOIL it back, it'll still give you 4a squared minus 9.
Oh, wait, no.
Yep.
Would we still have to do it more?
Note, so 2a just has an exponent of 1, so you can't do it.
Okay. What happens when the other one's at the back? Like the square? We just do like the same.
It's the same thing. It's just in opposite order, which is fine. It's still a difference of squares. So the next one I have 49 minus 64m squared. So even though my variable is not first, because both of them have a square root and the subtractions in the middle, it's still considered a difference of squares. So try to figure out what the difference of squares for this guy is going to be. Camilla? Yeah.
Minus 7 and 8 on the side.
Close. You got the right stuff right, but what should come first?
Oh, and 7.
Yeah. So what would it be?
7 minus 8
Mhm.
and then 7 minus 8.
Here we go. So for this one, since your constant is first, your constant should be the first term in your bracket and then your variable part. It's whatever order it appears in is the order in which you write it. So you guys are probably finding this much easier than the other factoring stuff. So any questions about difference of squares? No? Pretty easy. We'll do two more. Okay, we'll do, J is a tricky one. So we'll do I. You guys can do G on your own. So let's do I. So we have 81x squared minus 121p squared. So I think this is the last page of your notes. So try to figure out what I is going to be.
Wait, where is that?
So it should be the last page. Then I'll give you the last page. It's a big page.
Oh. Please.
It's one singular page by itself.
Oh, yeah, got it.
Yes, that one.
Nope. Can I just write it on the paper?
Yeah, just write it on the paper. It's fine. So if someone has an answer, feel free to share it when you have it. Brooklyn.
I got 9x.
Okay, guys, I need to hear Brooklyn. Yep.
9x plus 11.
Okay.
And the other one, 9x 2, 11.
Yep. Perfect. So that is your answer. You can't do anything else. That's it.
Okay, so it matters like the order in which.
Yeah, so if X is first, you put the one with X first, and then if it comes last, you put that one
But it
last.
doesn't matter if it's.
No, if it's-
last first or
yeah, it
last.
doesn't matter.
Okay.
Okay, I'm gonna give you guys a chance to do J. Try to do it on your own. So I have 49 minus 9 plus Z all squared. So take like a minute or two to try to figure out how you would solve this. If you're stumped, that's fine. But just try to figure out what you can do to help you solve this.
Wait, I
Yes, Camilla?
don't think this is right, but, is it 7, minus 9 Z, and then 7 plus 9 Z?
Yeah. That's you can, but you have to now. Do you have like terms in there? Okay. So what Camilla said was right. So we have to take the square root of 9 plus Z squared. And what's the square root of 9 plus Z squared? 9 plus Z, because all we're doing is taking this exponent and dividing it by 2. Nope, we don't have to square root the anything inside the bracket. Nope, you don't have. So when you have something like this, all you're doing is getting rid of the exponent. That's it. So what's half of 2? Is just 1. So you're just going to be left with 9 plus Z. Okay? And then what's the square root of 49? 7. So in one of your brackets, you are going to have 7 7 minus 9 plus z. And in your other bracket, you are going to have 7 plus 9 plus z. So now I have to simplify my brackets.
Wait, so how did it go to 9 plus z?
Because when we have an exponent of 2, what did I say? Whenever you're square rooting an exponent, what are you doing to the exponent? Dividing it by what? So whenever you take a square root of an exponent, you're just dividing it by 2, right? So what's my exponent in 9 plus z squared? 2. So what's 2 divided by 2? 1,
What?
right? Which means I get rid of that exponent. So I'm just left with 9 plus z.
Okay.
So when I distribute a negative into a bracket, what happens to all of the signs? They change. So my positive 9 becomes negative 9, and my positive z becomes minus z. And then I have 7 plus 9 plus z. So what does my first bracket become? Simplify algebra. Brooklyn?
I have a question.
Yeah.
What did you do for the second step?
For this guy?
Yeah, after that. How did you get 70.9 on the?
Oh,
and then-
so because here we have what? A negative, right?
Yeah.
And I have to distribute, which means I have to multiply that negative into my bracket. So my positives become negative and my negatives become positive. So what does my first bracket simplify into? Olivia.
-2 -z.
Okay, and my second one?
16. Do you do it for the other bracket too?
Well, the other bracket, because there's a positive on the outside,
Yeah.
it just stays the same.
Okay, even if it was a negative?
Yeah.
Yeah, okay.
Oh, okay, so then you distribute after the
Mhm.
bracket?
Yep. Finish the back.
Wait, so would you distribute -7 or just the negative?
Just the negative.
Why would you do?
Because if you have a negative on the outside of a bracket, it's an imaginary -1.
Wait, so then what does -7 just stay there?
Which -7?
For the second step, I think. After you square root it. The one with the rainbow.
Oh, that? This one?
Yeah,
No, you just multiply -1 into your bracket.
okay, and then we just leave the 7 where it is?
Yep, just leave the 7, it stays untouched. So Camilla, you were almost there.
So off.
No, you just forgot to simplify. That's it. You had 7 minus 9 plus z and 7 plus 9 plus z. The only thing you forgot to do is simplify the bracket. Yep, that's it. I would star this one because I may give you something like this.
What did you say though? Would you say like?
Ask me after, see if you remember. And now the easy part, difference of, or perfect square trinomials. So the first one we have is x squared plus 8x plus 16. So what's my product? 16, and my sum is 8. So two numbers that multiply to 16 and add up to 8. Remember, the perfect square trinomial means they have to be the same number. 4 times 4. So 4 times 4 is 16, which is good. And 4 plus 4 is 8, which is also good. So Omer, what are my two brackets going to be? What numbers did you use? So it's going to be x plus 4 and x plus 4, which is the same thing as saying x plus 4 to the power of 2. Yeah.
Can you explain that again?
So the sum is the number in front of your x squared, which in this case is 1, multiplied by the last number. So what's 1 times 16? 16. Your sum is your middle.
You know, I get that, but how would you know that it's a perfect?
When the two factors you use are the same. So in this case, it was 4 and 4.
Okay,
Yeah.
oh,
Oh, so if it was like,
I'll do the next one. It's the same one. It's a similar one.
but if it was like, for example, 8 and 2, like I know that would work.
That would not be a perfect square. Okay, my next one I have y squared minus 14y plus 49. So what's my product here? Olivia? Yeah, and my sum? So what two numbers would work? Positive or negative? Olivia? Negative 7. So negative 7 times negative 7 is equal to positive 49. And negative 7 plus negative 7 gives me negative 14, which is what we want because that's my middle term. So what are my brackets or what are my factors going to consist of? Rita? Yep, which is the same thing as saying? Yep. Easy stuff. Yep, what's up?
oh, wait, wait, wait.
Okay, and then the last one, let's see if you guys can do on your own. Z squared minus 9z plus 9.
Remember this one? Is it minus whether the numbers are negative or positive?
But they both have to be either both negative or both positive. Well, is this one even possible to begin with? Nope. This one is not possible. And why is it not possible? Olivia?
The square root, like to get 9 and sum of -9 would be -3, but -3 plus
Yep.
-3 is negative.
So negative 3 times negative 3 is positive 9, which is good. But negative 3 plus negative 3 gives me negative 6, which is not what we have in the middle. So if that's the case, what would my middle term have to be for this to work? Someone said it. Yeah, it would have to be z squared minus 6z plus 9. And that way would be x minus 3 times x minus 3 or x minus 3 squared. So this one will only work if my middle term is negative 6z. Other than that, if we have negative 9z, it doesn't work ever. Yep.
On the test, if you get a question like this, would you want this, right? Like it would work with.
No, I would just say factor if possible. And if it's not possible, you just write not possible. So we'll do one of these harder ones. Well, not harder ones, just has a number in front of the what's it called? The t squared, the first term. So we have 9t squared plus 6t plus 1. So what is my product? Remember, it's my first number in the coefficient of t squared times the last number. So what's my product? Emma?
9,
Yep, 9. And what's my sum?
6.
6. So what is going to give me a product of 9 and a sum of 6? 3. Good. So now what we're going to do is we're going to factor using the grouping method. So it'll be 9t squared plus 3t plus 3t plus 1. So again, we're going to look at our first two terms first. So what's the greatest common factor between 9t squared and 3t? 3 what? 3t. Which means I divide each of these by 3t. So 9 divided by 3 gives me 3. T squared divided by t is just t. And then the next one is 3t divided by 3t. So anything divided by itself gives me what? 1. Okay. And now we look at my second set of terms. So what's the biggest common factor between 3t plus 1? What is the only common factor? Just 1. So what are both my factors going to be? Olivia?
3t plus 1, 3t plus 1. Or 3t plus 1.
Yep, there we go. Okay. So do E on your own and try to, that way you can practice your factor by grouping if you want. Yes, Rita? Mhm.
So, during this math, how can we put like 3t into like the trinomial, but for like above and you didn't put like 4 and 4 in?
Because what did you notice about the number in front of your x squared or your first variable? It was always what? Did we have a number at the beginning? No. That's why.
Okay.
So try doing E on your own. See if you guys can get it. Anyone get an answer?
I got 2m minus 3 squared.
Okay, 2m minus 3 squared? Okay, let's try this. So my product is going to be 4 times negative 9, which gives me what? Negative 36. My sum is what? So what are two numbers that multiply to negative 36 and give me negative 12? Does this even work? It only works if this is what? Positive. So if we change it to positive, what is our actual, what would it be? Yes, Brooklyn? Yeah, so we're changing it to positive 9, just for the sake of this working. So negative 6 times negative 6 is 36. And negative 6 plus negative 6 is equal to 12, negative 12, which is good. So we're going to get 4m squared minus 6m minus 6m. And remember, we're changing my last one to plus 9. So let's take a look at both of our first terms. What is the greatest common factor between 4m squared and negative 6m? Olivia. Which means we're dividing both of these by 2m. So what's left in my bracket? So 4 divided by 2 is what? 2, and m squared divided by m. And then 6m divided by 2m is negative what? 3. So we're going to get the same answer you got anyways. So then we look at negative 6m and positive 9. What's the greatest common factor? Positive or negative? Negative 3. So we're left with 2m minus 3. So what's my final answer going to be? Jade?
2m minus 3 to the power of 2.
Yep, perfect. There we go. Yes, Olivia?
Why is it negative?
What do you mean, negative 3?
Like,
Oh,
instead of why is it negative 3 as opposed to?
because then we're going to get, if we factor out the positive 3, we're going to be left with negative 2m plus 3 in the bracket, which means I have to factor out a negative 1 still.
Oh, okay.
So I want to avoid all of that.
Okay, then how do we know when to avoid that?
Just look at the sign, the number in front of the variable. If it's a negative, factor out a negative. Okay, and then we have, you guys will do F on your own. So this one, and then we'll do the last couple of examples and then probably call it a day after that. So for the last one, we want to determine the value of k so that each trinomial is a perfect square. So we have x squared plus kx is equal to 49. So what is my product in this trinomial over here? Olivia? 49. So remember, in order for it to be a perfect square trinomial, both numbers to multiply to get to 49 have to be the same. So what are the only two numbers that multiplied together give me 49? Read up. 7 times 7 is equal to 49, which means my sum has to be what? Right, because 7 plus 7 is equal to 14. So what has to go in for k then? 14. So x squared plus 14x plus 49. Yes?
How would you do the crisscross method with that one? Would it just
You-
be like a 1 in the middle?
No, it would be K, but you can't do crisscross when you have to, yeah.
I'm confused, why is the answer if like last,
Why
last
it-
question we just did?
Mhm.
We have to like find the greatest common factor.
So what do you notice in front of x squared? Do I have a number?
Oh, no.
Yeah, that's why.
Okay, so you don't do it, okay.
So my next one is 9x squared plus k, so we don't know what k is, plus 25. So what is my product here? First term multiplied by the last term. What's my product? Read up. 225. So what two numbers that are the same multiply to give me 225? No. Remember, because this guy has a number in front of my x squared, my product is the number in front of the x squared multiplied by my number at the end. So what would my two numbers that are the same be to multiply to get 225? Jade? 15 times 15 gives me 225, which means what does my sum have to be? Which is what? Good. So what is my whole equation going to look like now? Jade?
9x squared
Mhm.
plus 30x plus 25.
Yep, there we go. And then for C, try to do on your own and then let me know what the answer is. So this one's different because we're not solving for the middle term, we're solving for our last one. So in this case, you're looking for two numbers that are the same that add up to negative 12. So to help you guys out, what are two numbers that add up to negative 12 that are the same? So what does my product have to be then?
36.
So now you're going to figure out what number multiplied by 4 gives me positive 36. So what is my k? So what's my whole equation? 4x squared minus 12x plus what? 9.
Wait a minute. Oh,